Hey, hello guys. So today we'll go on to learn something about vectors and scalars, because these two are the most basic quantities that you will be dealing with in the whole of physics. Okay, so I've already given the intro in my first lecture. So now we'll just go a bit more deep into what are these two quantities and understand the exact concept of these two quantities. So I've already learned that physical quantities, these are of two types, vector and scalar. If someone asks you what is the major difference, the basic difference between these two is that a vector has its property of both magnitude and a sense of direction. Okay, whereas a scalar has only magnitude. It has no directional sense. Now what is the meaning of this thing, that magnitude and direction? What is the meaning? Okay, so let us dive deeper into it. Okay, so let me draw some xy axes. Okay, so now suppose this is my reference frame. This is the origin, the starting point of observation of all events. This is my x-axis, this is my y-axis, any 2D plane I am taking. Okay, now suppose there is a point over here, point 1. I am naming it point 1, and there is another point 2 over here. So suppose on this xy plane a person is walking. Okay, now he can go from point 1 to point 2 in various ways. He can go via a straight line. He can go via, let me change the color. He can walk in any zigzag fashion, right? Now if he is too drunk, okay, so he can go in any fashion whatsoever. So what is the distance covered by him? Can you tell me? The distance covered by him will be the total path length that is taken along this. So you have to add, so case A, B and C. Okay, suppose 3 cases are there, A, B, C. So in each time the distance covered will be different, correct? Distance covered in case A not equals to case B is not equals to in case C, right? In all the 3 cases it's different, since the path length is different, right? How to measure path length? You have to measure the exact, you have to track exact points through which a person has traveled or any car has traveled. Okay, so that exact path length is the distance covered from point 1 to point 2. So in each case the distance covered is different. Whereas now we are coming to another thing called the displacement. What is the displacement of the body from point 1 to point 2? That is given okay, so point 1, this is point 2. So the displacement will be given by the straight line joining from point 1 to point 2. This is the displacement. No other undulations you will get, no path length, only the straight line connecting from point 1 to point 2 is the magnitude of displacement. Now when you have to refer to displacement, it contains 2 things. It has the magnitude, which is, suppose the length of this is from here to here, the straight line length is d12, the magnitude will be d12. And what is the direction? The displacement means it will also say the direction of it. Means it is going in this xy plane from point 1 to point 2. If there is an arrow, what is the angle it is? How to give the direction? You can say in broad terms that it is due northeast, right? You can specify like that, northeast. Or in a more mathematical terms, you can specify the angle. Okay, so you can also specify the angle, whatever y is there, whatever x is there, you can give delta y by delta x. Okay, tan inverse. So now we know. Okay, so now we summarize this thing, we draw it again. And we take 2 points, point 1, point 2, and so from point 1 to point 2, if I draw a straight line with an arrow at the finishing point, arrowhead should be at the finishing point, right? So this thing is called the displacement vector, this whole thing. So what is the magnitude of this displacement vector? We have to name something. Displacement vector, so d with this thing, or simply this. Okay, so we call it the displacement vector. From point 1 to point 2. Now what is the displacement? What is the length of it? I told you d12. d12, suppose it is 4 meters, right? Okay, so magnitude of the displacement vector is d12, 4 meters. This means magnitude. Okay, and its angle also has to be specified. Now what is the distance covered? So if someone walks on a straight line from point 1 to 2, then its displacement and distance, magnitude of the displacement and the distance covered will be equal. Okay, very important point. Okay, so we'll move ahead with another example, that is, you already know about speed, right? Suppose I draw a car and it is going at certain speed. Generally you say speed equals to, suppose 30 km/h. Now if it is in a reference frame, correct, now you don't know it is moving with 30 km/h, but in which direction? So for that there comes another term called velocity. Okay, so velocity has both magnitude and direction. So the mod of the velocity, modulus, or the magnitude of the velocity, is the speed of the car. Okay, but it also has direction. So when we say what is the velocity v of the car, we have to say that the car is moving with 30 km/h, and we have to say the direction, that is moving due east. Okay, if this is east. Okay, so this is the major difference. So there are many quantities we'll be dealing with, because in physics the main thing is seeing the difference between vectors and scalars, and vectors will really come largely into play in the whole of physics. Okay, so by examples we have seen that displacement, it's a vector quantity. And what is a scalar? Scalar version of displacement is the distance. Not the scalar version, not exactly same. The magnitude only becomes same when anything is moving in a straight line. In a zigzag fashion, even the magnitudes of displacement and distance are not same. In the very first problem that I had taken in this lecture, right? If you go in a zigzag way, the magnitude of displacement and distance are largely different. Okay, another thing is we have learned is velocity. What is the scalar version of speed? The scalar version of it is speed. Okay, magnitude of velocity is the speed. And with speed, if we attach the sense of direction, that is in which direction it is going, then it becomes velocity. There are many other terms you will become knowing, like acceleration. That also is a vector quantity. Okay, so the notations of vector quantity, mathematical representations of it, that we'll discuss in the next class. Okay, so and another thing I wanted to say is that is a small important concept, that the magnitude of the displacement is the minimum distance between 2 points. Okay, just ponder on it. I want you to think, not just like, otherwise you can read these things from any book, any theory book you go and read. I want to give you certain insights, certain inputs on which you can think upon. That is what makes physics very interesting, right? So just think upon it, that the magnitude of displacement, what we already discussed, right? Where's the first? Oh, that I was deleted. So just think upon it. I'll draw it again for you. So from any point 1 to any point 2, distance covered can be huge. You can go here, then here, then you can come back, right? But what is the minimum path length that you can take between point 1 to point 2? It is this straight path from point 1 to point 2, which is the magnitude of the displacement. So minimum of d12 is the mode of displacement. Right? Just ponder on it. Okay guys, so with this, today we'll stop. If you have liked this video, then please give a like and share with all your other friends, so that we can communicate and we can build a community over here, and we can discuss more theories, more problems, okay, and build a forum which will grow on and help to create a good vibe of physics over here. And also, to stay tuned, please subscribe. Okay, click the subscribe button. It's just below this in red. Okay, till then, keep on studying and keep on learning more and more about physics, and keep enjoying physics. Then it will seep into you more, and you can do it more easily in a far better way. Okay guys, bye bye, see you.